Welcome to this short demonstration of Edgecam Solid Machinist. Today we'll concentrate on the turning environment. The presentation will not only show you Edgecam's intuitive machining interface, but will further emphasise how Edgecam respects the integrity of a solid model by importing it without translation and thus allowing Edgecam machining to be associative to the solid model. We've begun by opening the solid model and using Edgecam's automatic feature finding have created both milling and turning attributes. You can further feature find if you want to. The features lie on the left hand side. We'll take the part through into manufacturing. We choose our machine tool, we set our stock condition and the parts stick out, how much protrudes from the chuck, and now we load a solid model which represents the kinematics of the machine tool. We're ready to start machining. Let's move the drawing view to a convenient position, the turn view, and using the features down the left hand side, Edgecam offers us a number of potential machining commands. In this case I'm going to select rough turning operation. Observe the intuitive dialog interface, so Edgecam prompts the user and advises him or her as to what particular machining condition they are now affecting. We move into the tool store and we select appropriate C and MG tool to perform this particular work. Simple click of the button and the toolpath is now created. The stock is still present, that's the original stock from the billet. We can update the stock and Edgecam will melt away the stock, showing us the latest stock condition. This is very important to produce toolpaths that do not cut fresh air. It respects the stock. We move further ahead, we pick the same feature and now we go for our finish turning operation. Again the same intuitive dialog box is used and we're going to pick a D&MG insert. The tool store can be loaded from Edgecam, or indeed you can create your own tooling, as you can see here. So the dialog box is now dismissed and the finish turning command is now created. If we feel we need to edit any of these commands, we can go back, make an edit. We can play the toolpath as you can see on the screen using the scroll bar. If we feel there's any attribute in the turning that needs to be altered, we can go back and change that also. We can now go into the simulate machining software. This is where we see the toolpath and the stock and the machine kinematics being represented. This is the check for the machinist to make sure that there are no collisions. We're also checking that the tool and the tool posts do not collide against the chuck, and obviously we're looking for the right type of machining condition as well. We're now going to see the D&MG tool do our finish turning. Let's move back and let's, again, selecting one of the features which are associative to the solid model, create a rough grooving operation. Again, the operation style is the same as the previous commands. Cancellation is supported. We place a stock amount in here, and again we're going to select, in this particular instance, a 4mm external grooving tool. We can update the stock and this will melt away the current stock, revealing the current stock condition. Again, using the same feature, we'll go for a finish grooving operation. We can use the same tool in this particular case. See how quickly and how easily this is achieved. We now got to turn our attention to the milling aspect of this particular component. We're going to select the feature. It's offered us a whole operation, and again the intuitive dialog box advises the user as to how to produce the best type of toolpath, concerning itself with the mill mode, the position of the tool, and the diameter is automatically chosen of this tool, as again it is associative to the solid model. The PCD is now created and the stock again is automatically updated. We're going to move further ahead now and machine the pockets and the feature towards the front part of this component. So we're going to select a roughing command, and Edgecam will prompt us for the tool orientation. In this case obviously it's axial, and rotary machining we need C-axis output. We're prompted to digitize the feature, and now again Edgecam, if you will, holds our hand and takes us through a number of decisions which allow us to produce a successful roughing toolpath on the open face feature, which you'll see located on the shoulder of this particular component. Again, everything is associative as it says on the screen. Toolpath is now created. Moving further ahead and looking at the hexagon that we see on the front of this component, we're going to do some profile milling. So the same approach is adopted. We select the feature that needs to be profile machined, and again a similar intuitive dialog box is now displayed advising the user on how to produce the toolpath. So the toolpath is produced, and we can simulate in Edgecam the toolpath if we wish to. We can go back to that toolpath and begin to make alterations. In this case, let's change the cut increment, thus reducing cycle time. To double check that we have no collisions, let's move back into the machine simulator, and rather than watching the turning, we can ask Edgecam to stop at every tool change and fast forward over the initial set of turning, so we are collision free up to that stage. Now we'll invite Edgecam to display the machining of the open pocket, and again we're watching for collision not just of the tool, but we're looking for collision on the tool holder and also the turret. And again, let's zoom in and check the machining of the hexagon profile. This has all been done in C-axis, as you can see on the screen. So let's move back. We're moving towards the final stages now of the demonstration. What we simply want to do now is just take the tool to tool change, and we'll orient the tool so it now aligns to the pocket that we see on the top face. So we call this the radial position in Edgecam. So we'll go ahead, select a roughing command as we saw in the first instance, but this time the mode is planar. We do not wish the chuck to actually move in this particular case. It's a plain pocket on the top face. As we saw before, the same dialog command is being used. We'll use a slightly larger 8mm end mill in this particular case. Again, we'll just check those levels and depths, which are again associative to the solid model, and we can see that we've now produced the slot on the top face. So we're just going to save the file away there, and now we're going to come back and reload the model. Even though we've extensively machined the part and checked it, we've now been informed by design department that the part has actually changed. So you can see us reloading the solid model. Notice how the shape changes. Observe there's less PCD holes. The hexagon's changed to a square, and down the left hand panel in bold Edgecam points out which features are changed. Also notice the groove has moved back down the Z-axis. It's not a problem to Edgecam. We can just simply now ask Edgecam to regenerate, and all the previous and original tool paths are now moved into the new position to accommodate the design change, and now the machining is completely safe. Thus we've reached the conclusion of this particular demonstration, how Edgecam remains associative to the solid model. Thank you for your interest.